It's pretty amazing. So let's jump into our topic today. So as we know, wireless LAN APs are categorized as FAT, FET, or Cloud APs. And among these AP types, FET APs must work together with wireless LAN AC. So this is actually an AC plus FET AP architecture. And in this networking architecture, an AC centrally configures and manages FET APs, and the CAPWeb protocol is used for communication between the AC and APs. So how does an AP go online on an AC? And what if an AP fails to go online? And how can we troubleshoot the fault? So that's exactly where we're gonna dive into today. So to start off, let me generally introduce you the contents. So firstly, we will learn about the AP onboarding process. That is the process for an AP to go online on an AC. And then we will look through the common problems that may occur on the live network and how to troubleshoot them. And finally, I will show you how to obtain related documents so that you can get more information about AP onboardings by yourself. So let's get started. So let's start with the overall AP onboarding process. So there are several phases in the whole process. Specifically, we have AP address allocation for the AP, and we have AC discovery, AP access control, configuration delivery, CAPWAP tunnel maintenance, and configuration update. And in addition, there are two optional phases, DTLS connection and version upgrade. So what are specific operations performed by APs and ACs in each phase? So let's check them one by one. And in the first phase, the AP must obtain an IP address so that it can communicate with the AC. This is the very first step for the communication on the wireless LAN. So an AP can obtain an IP address in two ways, in static or DHCP mode. So in static mode, you can log into the AP and configure a static IP address for it manually. But this method is it is quite simple. However, if there are a large number of APs, the configuration is complex. Therefore, we have another method for an AP to obtain an IP address. That is through DHCP. So in the DHCP mode, the AP dynamically obtains an IP address from a DHCP server. As shown in the figure on the left, the AP broadcasts a DHCP discover a message to request a response from a DHCP server. So after receiving the message, a DHCP server responds to the AP. After selecting one DHCP server, the AP notifies other DHCP servers that it has selected a DHCP server. Then the selected DHCP server assigns an IP address to the AP, and during this process, more information can be carried in the option field of message sent to the AP. Among these options, option 43 is the most common one. So how does it work? We will find the answer in the following phases, which is AC discovery. So after obtaining an IP address, the AP start to search for an AC. If the AP and AC are deployed on a layer 2 network, the AP can broadcast packets to discover the AC. In this case, you do not need to specify the IP address of the AC. However, if the AP and AC are connected across a layer 3 network, the AP cannot discover the AC in broadcast mode because they belong to different broadcast domains. So now, it's option 43 we just mentioned that comes into play. So an AP can discover an AC based on the AC's IP address carried in the option 43 field. And after receiving the discovery request message, the AC unicast a discovery response message to AP, and the discovery response packet contains the AC name, AC version, and DTL status. So if AP receives discovery response message from multiple ACs, its next an AC based on the AC priority and the number of APs connected to the AC. And we can also see the optional DTLs here. So if DTLs is enabled on the AC, the AP starts DTLS negotiation to establish a DTLS connection with the AC. So after the DTLS connection is set up, packets between the AP and AC are encrypted, making transmission more secure. Then we could move to the AP access control. So after AP successfully discovers the AC and establish a session with it, they start to establish a control channel with each other. As we can see in the flowchart on the right, the AC determines whether to allow the AP to access the network based on various factors, so including the AP blacklist, whitelist, AP authentication mode, and whether the AP has been imported. So after the AC determines that AP can access the network, the AP checks whether its current system software version is the same as the expected software version on the AC. If they are inconsistent, you need to upgrade the version. If they are consistent, version matching is not needed. And the next phase, configuration delivery by the AC. So when the AP version upgrade is not needed or the AP has been upgraded successfully, the AC starts to deliver configurations to AP. So first, the AP sends its current configuration to the AC and enters the configure state. After receiving the initial configuration from the AC, the AP performs the initial configuration based on the message content. Actually, in this phase, the AC does not deliver service configurations. Instead, it delivers service configurations only after the caplock link is established. And after completing the initial configuration, the AP would notify the AC of the execution result. The AC then updates AP information as required. And then we go to caplock tunnel maintenance. So after the preceding phases, the AP has gone online on the AC. Then we need to maintain the caplock tunnel between the AC and AP. The AP and AC send keep alive and echo message to each other to detect the connectivity of the data tunnel and the control tunnel respectively. The AP start the timer to send keep alive and echo message and start the tunnel detection timeout timer. So if the AP receives keep alive and echo message within a specific period, it resets the timeout timer. Otherwise, it determines a message timeout. Then we come to the configuration update phase. So after the caplock link is established, the AC delivers service configurations to the AP. And after receiving configuration information from the AC, the AP can provide wireless LAN service based on the service configured on the AC. All right, so this is the entire process for AP onboarding process. However, during this phase, some problems may cause this AP to fail to go online. So for the next part, I will analyze several common problems, locate the causes, and introduce corresponding solutions. So the first common case is that static AP address configuration error. So if an error occurs in configuring a static IP address for an AP, the AP fails to go online. There are several possible causes for this fault. So firstly, the static IP address of the AP is not unique and conflicts with that of another device on the network. Secondly, in layer 2 networking, the static IP address of the AP is not the same network segment as that of the AC. And in layer 3 networking, the egress gateway is not configured for the AP, and the AP is not restarted to make the configured static IP address take effect. That is also a very possible cause. So remember to restart your AP each time you change something. So to solve all these problems, we need to log into the AP and check its IP address, then check whether information about the static IP address is in fact is correct. And if the IP address is incorrectly configured, change the IP address allocation mode of the AP to DHCP mode, or change the static IP address of the AP to a valid one. And then restart the AP for the configuration to take effect. And the next one, sorry, is a insufficient license resource, or AP limit reached. So this is a very common problem causing an AP to fail to go online. The license resources are insufficient, or the number of APs reaches the maximum AC specification. So upon such problems, we can check the license resource usage. If the current resource usage reaches the authorized value of the license file, new APs cannot go online. In this case, apply for and load a new license file. So if the number of resources does not exceed the authorized value of the license file, so check whether the number of the APs in normal state exceeds the maximum number of APs supported by the AC. So if the number of APs managed by the AC exceeds the specification, replan the network properly based on the number of the APs that can be managed by the AC. The next problem is that the AC's IP address is not or incorrectly specified on an AP. This will also cause an AP to fail to go online. The method for resolving this problem varies depending on networking mode. So on a layer 2 network, the AP can discover the AC in broadcast mode without the need to manually specify the AC's IP address. And on a layer 3 network, however, you must specify the AC's IP address. Otherwise, the AP cannot discover the AC in broadcast mode. So two solutions are available depending on the AP onboarding mode configuration. So if the AP configured to go online using a static IP address, check whether the AP's IP address is unique and whether the IP gateway and AC's IP address are correctly specified. And if the AC's IP address is now specified or the specified IP address is incorrect, specify the AC's IP address for the AP and then restart the AP for the configuration to take effect. And if the AP is configured to go online using DHCP and the AP and AC are connected to 3 network, check whether option 43 is configured in the address pool. Note that if the VRRP has networking is deployed, we must specify the virtual IP address as a cap web source address on the ACs in the option 43 field. We know that each AC requires the configuration of at least 1 or 2 IP addresses. VLAN interfaces or loopback interfaces. In this manner, APs managed by the AC can learn the specific IP address or the IP addresses of the specified interface and set up capweb tunnels with the AC. This IP address or interface is also known as the CAPWAP source address or interface. So if CAPWAP source interface or address is not configured on the AC, the AP will fail to go online. To solve this problem, we need to check whether the CAPWAP source interface or source address is configured. If the source interface is configured, check whether the IP address is correctly configured for the interface. If neither of the CAPWAP source interface or the CAPWAP source address is configured, so configure one as required. And this is another problem. The MAC address and serial number of an AP specified on the AC are inconsistent with those of the AP. So to solve this problem, check the MAC address and serial number of the AP. So if MAC address and serial number displayed on the AC are consistent with actual information, we need to delete the AP and correctly import this information on the AC. The next very common problem that may cause an AP to fail to go online is a version mismatch between the AC and the AP. So we need to obtain the version mapping between ACs and APs in this link, this one. Let me show you. Let's click this one. Let's see what we can get. Okay, download the document view browser. Open it. Okay, so in this part we can see this whole Excel, and we have wireless name AC on the left, and we have fit AP on the top. So this is a version. So and this is a version of the wireless NAND AC, and this is version of the fit AP. So what we can check is see if they are match or not according to this gray part and green part. The Y stands for yes, and this is no. So you can check the match or not, and we can also check between like wireless NAND fat AP and fit AP. So that's it. Let's go back to our slides. Okay, so due to the limited time, we have to quickly move to the third part. You may curious about how to find those useful information, just like the version mapping, as we discussed before. So here it is. For the last part, I'd like to introduce how to obtain documents related to AP onboarding and troubleshooting. So you can get more details. Let me show you. So first, we got a very good website or tools. I can call it TechNotes. Click TechNotes. Okay. So TechNotes is usually practice oriented and are short technical document that describes specific issues and provide solutions. And Huawei engineers work with customers around the world to provide solutions to the most complex problems and record their experience in TechNotes. So TechNotes details specific issues covering topics such as design, configuration, maintenance, and troubleshooting. So let's try to find something useful on it. Maybe we could try to find the version mapping we mentioned before. So we're talking about wireless names, so now this is TechNotes. We have these different types of the products on the top of the website. Then we click wireless name, boom, we go here. So if we want to find something about the version mapping. So we can go to like this one, how an AP joins an AC and troubleshooting any join failures. And we go here, and we got all this here. And since I've already checked it before, they have make it blue, I guess. And this is the version of the AP and AC do not match. That's what we want. We click this one. And there's a quick reference for wireless NAND AP version mapping and models. So that's how we find this useful message through our tick notes. And okay, so that's all for the entire AP onboarding process sharing. So if you have any question about today's sharing, so please feel free to leave it on the chat box, and I will use some of the question to answer. And for the others, our specialist will provide answers for you as well. So let me open the chat box. How could we assign IP address? Okay, so I see the question of Alice. I think it's a good review for us to answer this question. How could we assign IP addresses to the APs? We can go back to our slides, I guess. I believe it's on slides 4. Yeah, that's it. So in order to do the IP address allocation, we have two methods, which is static mode. So a user logs into AP and manually configures its IP address. It is very simple, but when you have a large number of APs to be configured, maybe you'd better to use DHCP mode. In this mode, the AP serves as a DHCP client and request a IP address from the DHCP server. So you don't need to like assign IP address for each AP by yourself. And the second one, what would be applied if an AP cannot discover an AC in broadcast mode in layer 3 network? I think this one is only slide 5, I guess, because we have two, sorry, let me make it bigger. Because we have two situations in the layer 2 networking and also layer 3 networking. So for the situation 1 in the layer 2 networking, so APs can send the discovery request message in broadcast. But if we are in the layer 3 networking, the broadcast won't be able to find the AC. So what we need is the option 43. So it is used to obtain the AC's IP address. We can the AC's version, the name's IP address would be all carried in the option 43. And so if we use this one, we can help AP to find AC in the layer 3 networking. And can go to next question. what could we do if the versions of the AP and AC do not match? Okay, that's a good question. So maybe I can show you a more detailed way to find the nodes and find this version map. So we can always remember one website. It's a.huawei.com and /en stands for English version, I guess. And we can go to this part, technical support. And then we go to technical support home, this one. And at the bottom of this page, we can find the tick nodes we mentioned before. Boom, this is our preliminary tick nodes. You can go to the wireless LAN, because our topic is wireless LAN today. And we have different topics here. And today we just choose this one because we are looking for different solutions for our failures. And we take this one. And here, the versions of AP and AC do not match. And we can see we also got a lot of other solutions like AP is blacklist, how should we do in the AP upgrade fails, all kinds of things. You can find all in this page. And we click the version of the AP and AC do not match. And they will tell you the possible causes and the specific troubleshooting procedure and also the link. I think that's probably most people want. And this one, quick reference for wireless AP version mapping and models. And you click this one. Okay. And we could just download it and open it. And then all of these versions of here. You can look at this to check if they are matched or not. And we back to then. What are the possible reasons when we filled in static IP address allocations? And I think that's a case one of our common problem. Let me find it. Possible reasons when we filled in static. I can show you our slides, which is more clear. This one. So those are the possible causes. The static IP address of the AP is not unique and conflicts with that of another device on the network. Or in layer 2 networking, the static IP address of the AP is not the same network segment as that of the AC. Or in the layer 3 networking, the egress gateway is not configured for the AP, or the AP is not restarted to make the configured static IP address to take effect. That's the possible causes, and we can also review how to solve this problem together. So the first step, we can log in the AP and check the IP address of the AP and check whether information about the static IP address in effect is correct, including the uniqueness of the IP address, gateway address, and AC's IP address. And if IP address is incorrectly configured, so we can change the IP address allocation mode to the to the DHCP mode and then restart the AP for the configuration to take effect. Or what we can also do is to change the static IP address of the AP to valid one and restart the AP for the change to take effect. So always remember you need to restart your AP when you need your change to take effect. And let me check. We've already answered. We got so many questions here. Let's see. What will be applied? What could we do if the versions of the team do not match? What are the possible reasons? Okay, specific. Who discovered of AP? As I see. Hi, Dongxiao. Are you here?
Yes. Hello, Fei. Yes, I
So,
am here.
so I was wondering, we
Mm-hmm.
get so many questions left in the chat box. Maybe we got some specialists for the other question about this one.
Yes, I think I already recorded these questions. I think the users they have more questions. They can go to the community and leave their questions there. Then you can answer them after the webinar end.
Yeah, I think that will be fine.
Okay, so now our webinar content already ended. Thanks for Fei-Yang's sharing. Now I would like to introduce you about our community competition. Can you see up my screen?
Yeah, very
Yes,
clear.
users, if you have any more questions, you can leave your questions in this activity post, and you can see there are 3 questions under this post. The answer time is from November 10th to November 30th. You can go to this post to answer the questions, and the users will have chance to win the Hikens rewards. And also you can see there is a survey about this webinar. Fill in this survey to feedback your opinion about this webinar to help us improve our webinars. So that's all the content for today. Thank you, Fei-Yang. Thank you for users watching.
Thanks, guys.
Okay, so that's all. The playback of this webinar and the materials will be upload to this post, to the community post. Bye bye.
See ya.